Yes, welcome. Today we are going to do our STM32 development board. It's a mini board that is going to run our projects, and therefore you are welcome to this tutorial. It will be a nice class, yes, and you will learn a lot. So you want to do this type of board. Before we do the board, we have to look at the data sheet for the STM32, which is here, and we have the symbol for this one. So you have to check in our KiCAD. We see whether we can have such a symbol before we proceed. We see whether it's okay. STM32. Let's see how this one looks like. Oh no. So we have this symbol. It's a very funny symbol. I don't like it. And since I don't like it, we are going to create our own. We are going to create our own symbol. We are going to create our own symbol based on these ones. So this one, let me edit this one first. So I rename it. So STM, correct. Okay. So we are going to create our own symbol based on these ones. So we come to symbol editor. This is a symbol editor. First close, we start again. Then the library, okay, it doesn't exist, so we look for it. So we come to symbol editor. So we don't know where we want to create, so you can create. You can add a library. So you can add a library. STM32 like that. Okay, global. Okay, so you can search for it here. STM32 F0. Where is F0? Then I look for the library. I have my own library, which is here, and there is nothing that is existing in it. So you have it there. So we come to this part. Then we have my libraries there. Okay, where I want to add the symbol, and my symbol is STM32 F0 31 kg K6. Yes, K6. STM32 F031 K6. Let me confirm. 031 K6 031 K6. Correct. Then we have the question mark here. The number of units per package is 1. So like that, and then we click OK. Then you have to arrange these ones. So move to above there. This one move. This one to below there. Then I can try to zoom in. Control save. So we're moving well. So the next thing we do is to start to insert our pins. Okay, we insert our pins. Our pins measurement, I'll give it how many millimeters? I'll give it 5.08 millimeters. These ones will remain like that. Then I'll give it the label. When you come to the data sheet, the first label is VDD pin 1. So it's very important you confirm with the label, which is pin 1. So like that. So I'll go on and insert all the pins. So I'll start with this one. Okay, second pin is XT1, which is pin number 2. And I hit OK. Yeah. Third pin is XT0, which is pin number 3. We'll hit OK. Place it there. Pin number 3 is NRST, which is pin number 3. and I'll hit OK. Let's place it there. Pin number 4 is VDDA. This is pin number 4. I'll click OK. Pin number 5 is A0. This is pin number 5. Click it there. Pin number 6 is A1. Number 6. Let it there. Pin number 7. Wait first. There must be an error. Pin number 7. There must be an error. Pin number 1. Oh yeah, this one. So I have to edit this one. So edit. I repeated number 3. So this is number 4. Okay, this is number 5. So those errors do happen. So you have to be very keen. You have to confirm and confirm. This is number 6. So I edit number 6. Then finally this is number 7. You edit number 7. We are in the right direction. So number 8. The number 8 is A2. This one is number H. Correct. So I can try to move this one a bit by 1. We will discuss from there next. Got to reduce it some. So we got to pin number 9. Pin number 9 is A3. This is pin number 9. Okay, I rotate it like that. Pin number 9. I'm trying to ensure that I have the correct thing. Pin number 10, A4. Pin number 11, A5. Pin number 12, A6. Pin number 13, A7. Pin number 14, B0. Number 14. Pin number 15. Pin number 15, B1. Number 15. Pin number 16, VSS. Control save. Then we go to pin number 17, VDD. So we will go all the way to pin number 32. So I'll go quickly to just insert up to pin number 32. we're going the other way direction to finish up. We are at pin number 25. So we go to pin number 26. D3. So we need to arrange it to make sure that it looks nice. So we start by the arrangement we see. So this size VSS VDD exactly. Here we have one. So this one again is exactly so VSS VDD one line exactly. So I think this one is correct. So we can add something input here. Control C. So we are at that point. Save all changes. Do we have any other changes that we need to do? So we can control save. This time around I'm not making the mistake of deleting it, so we'll see. So in this library, let me try to open it. Yeah, we have the symbol. So we come here, we try to see. Here we go. We have our symbol now. Now I have the symbol that I like using. I've done it by myself so that it can make my work very easy. And this is our STM32. You can move this one to inside here, move. This is our STM32. Yes, you can see it. It's a very nice one. The STM32 symbol that I have made it by myself. So if you want to be a very nice engineer, you should know how to do these things. I want to edit. I want to remove one question mark. Okay, like that. If you want to become a very nice engineer, you should be knowing how to do your own symbols also, because sometimes in the libraries you might not find a symbol that is fit for your design. Therefore, it's your duty to make sure that you are capable to do, or you are able to do such types of boards. So we will go on with our project. Now we have our STM32. Like that. And therefore, we need to proceed with other. We want to fill in other informations. So there we go. From there now, we need to add our capacitor. We start with the first capacitor. We want to connect pin 1, and pin 1, that is VDD, is connected to our capacitor. So we place our capacitor A for placing capacitors. Then we look for cap. And then we want to use the unpolarized one, small, but we need small. Okay, we place it where? We place it there. And then you can edit the value of our capacitor, which is 1000 farad. So it's 1000 mF, like that. Okay, you can move this this symbol to this side. We can still move this again to follow its brother to the side. Control save. Then we can go to wire, and then we connect this one here. So for power, we want to power this capacitor. We want to add some ground, so we can still use some symbols again. Sorry, ground GND. You're starting to do it very quickly, and to ground this one, so you rotate this one like that. Okay, you add some wire W like that. We need to power this one, so you hit P for power. Then you look for 3 volts, positive 1. Yes, correct. You place it somewhere there. Okay, you head your wire like that. You pick your wire W. Then you power this through that one. Control save. I'm going to do it very fast. Okay. After there, we need another capacitor. This one is 100 microfarad. I can edit it. This one I don't want it to be so big. But although the bigger the capacitor, these are coupling capacitors. So the bigger the capacitor, the less noisy your device will be, or the less your device will be affected by noise. So we go to the next, so I can copy this capacitor, copy, like that. We need to connect it to 20 microfarads, so we can edit it, 20 picofarads, 20 PF. Okay, I can still edit it. No, there is no need for space here, so, and, okay, like that. Now from this one goes to pin number 2 wire. Take it to pin number 2, like that. Control save. This pin number 2, we want to still balance the capacitor, and before we balance the capacitor, so this cap, you can move to this side. We have space there. I'll move again this one to this side, like that. Control save. So I want to put a crystal quartz. So I want to import a crystal quartz. We have a crystal quartz small. It is grounded. And that's crystal small. Exactly. Don't want big components, so it's a passive gadget. I put it there. somewhere there. Then we have this capacitor again, so we can copy this capacitor exactly the way it is and place it there. And then now add the connection of the quartz. So from the so I need to import wire W for one. You connect there, you connect this one from here to that point, Control save, and then we move our crystal from there to pin number 3 exterior. From here we go to pin number 3 like that, Control save. We are still doing our circuit. So you are moving in slowly but sure, slowly but sure, slowly but sure. So we have this capacitor connected to ground. So from here we go to this ground there, the same way as this one we'll do. They have print there, so Control save. Then we have this capacitor again somewhere, copy. We move it to this point like that. I can move this one, move to this direction. Move this one, move to this direction. Then I can move this one somewhere there. Yes. So you can reduce this one a bit like that. So from there we have a reset switch. So it's a push button switch. So I can place a component which is a push button switch. Push button switch. Okay, so I can rotate it the way I want it. I want it like that. And escape and place another component. That means they can get a nice switch. So you have a reset switch. So you can use the right switch. Have no any other better, so I can use this one. Like that. So we have this switch connected to number 4 wire. It goes all the way to pin number 4. Then we have this one connected to ground. Like that. This capacitor is grounded too. Like that. Then it comes from here to this. All these ones are filter capacitors or coupling capacitors. Okay, sorry, not connected, so we can finish the connection like that. Control save. So we are done with at least that bit part. We can connect number 31, 32, they are grounded. Number 31, pin VSS, and the brother or the cousins, they are connected like that. So we go to pin number 5. Pin number 5, we have a capacitor. So we copy, we bring it here like that. Copy, we take it to the other bit like that. Then we can change the value of these ones. So this one is 10 nanofarad. Then we can edit this one again value. This one is 1 UF. 1 UF. Yes. So we connect them to number 5. So we connect it like this. 5, and then we ground them. So you can copy, ground, copy, rotate R for rotation, like that. You ground them. Oh, look at it again. We go on with the project. So you have to put some resistor, so R, so you can place components, and then you have something F, this way, ferrite bead, small, and use a ferrite bead which is small, ferrite bead, that is too large, so you can use a smaller one, F bead like that. Okay, we place it there, we can rotate like that. You can still rotate. So, okay, no problem. So there's the part like that. Then we can wire it to this bead, copy this power, move with it. You can rotate it that, then bring it somewhere there. We power this pin, wire, powered, control save. So I don't want this one to be here, they might confuse you, so move, and move this one to this bit, move this one again, move, you can move them to this bit. Our schematic is taking shape at a quick pace. Static shape at a quick pace. So pin number 17 again, it needs some capacitor, so you come here, copy 100 farad capacitor, you copy it, place it there, then you go to connection number 17, wire, connect it like that, then it needs this power, so you can pick this power, copy again, bring it here, rotate R. These are my keyboard. I got it like that. You wire it like that. Control save. You need to ground everything, so you copy ground, bring it here. So this is VDD. Okay, wire like that. The reason why I like placing a component and connecting it is to avoid forgetting the connection. So you have to do it as quick as possible as you move. So we have number 16 again grounded. The VSS is grounded like that. Then you can control save. We are moving on very well. Now we have so many pins that are remaining, and the best way to connect these pins is by employment of labels. We will be using labels to connect all these remaining pins, because all these pins shall be powered to our pins on the board. We shall be having connectors on the board. We shall be powering all these pins. So how many pins do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 pins, it means we need around 28 pins because of power and other things to be connected. So I can take a pin of what by what. Let me calculate and see which one I'll take. The size of the pins I'll take. I want to know the types of pins that I will be using them to connect this schematic. I have counted 28 pins. Power to, how many do I need? Twenty-four plus 4. Yes, around 28 pins. For me to share these 28 pins, I'll do this. I'll put connectors. Let me see. So I'll input connectors. So connector 1, 01 times 04. This is my first connector. This is my first connector for the system rotator. Like that. I will place another connector, another part, 01 times. So we start with con 01 times 12. I will copy this one, and then I'll mirror using, is it X or Y? Is it X? No, Y. Is Y? Y. Then I move it now. I'll move one. Wait first. Can try to move this one a bit, so that I can copy this, move, and place these symbols where they will not disturb me. By design, move, it will not disturb me by design. And I will be doing the connection of pins. You can still move even these ones, when they don't have any bigger problem where they are, but it is good to arrange them nicely. That's work of a good engineer. So we have our pins, and we need all these pins connected. So we have to look for a way to connect them. And the best way is to use labels. So, if we decide to connect all these wires together, we'll have a web of wires here, like a spider web, and it will be very confusing. So to avoid this confusion, we can decide to label all these pins. So you can label them the way they have been labeled here. A1, you label A1, A2, A2. A1, you label them A1, A2, A2. Like that. So you come and take label. Label is here. You put label there. So the first one is A1. So you can copy. Can delete this one, then remove this one. A3. What's that happening? Move. Over A3 is this. Control save before you lose the data. So we proceed, we go. So we are at B. So far we are at B what? We are at B15. So you go on labeling. Let's go on. A8. R for rotation. A9. Enter. X. Y. Y is Y. So there is no way. You can use the shortcut, too bad. A10. A11. A12. SWDIO. SWDIO 0. Rotate. WC. We're moving very nicely. Control save. We proceed with other pins. A15. B3. B4. B5. B6. B7. Control 7. Now you start now wiring wire. This one, 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 this one. Control save. So you proceed to this one, 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 this one. Control save. This one, this one, and this one, this one, this one. A16 to pin 12, A5, pin 11. Like that. You connect everything where you want to connect to the pins. Like that. Control save. We are almost there. We are almost done with this PCB design. So you go to the next now. We want to concentrate now on the parts of the pins. Ground VPP. So we start here. Pin number 4. So we can mirror this one. X. Where is X? No. Y. Like that. Then move. You want the pins to start systematically. So that you can do a better connection. Now pin 1 is connected to ground. So we copy this ground. Copy. Pin 1 is connected to ground. Copy. Rotate R. Don't face any direction. There's nothing wrong with that. Ground facing any direction. So pin 1 is connected. So wire. like that. Pin 2 is connected to VPP. Pin 2 is connected to VPP, so we can add a symbol called VPP. VPP is always there, correct? So you bring it here like that. Then wire, very simple, connect it. You don't want to suffer. Control save. Pin we ground pin 1 on this side. Like that. Control save. Then we can copy this symbol for power. Like that. We add to pin number 2. Like that. I think we have finished the major connections. Now the next duty is to draw my wires A0 to A number 7. A0 to A number 7 from pin number 3. So we come to symbol here. Where is the symbol label? A0 and A1 and A2 and A3 and A4 and A5 and A6 and A7 and so I'm deciding how to arrange my sockets or my connectors on the other side. So we start from B0, B1, B0, B1. So we continue B0, and then B1. So we still have other pins remaining, like B7 now to B0, B1, B2, B2 is B2. B2. We have B2 in this schematic, B7, B3, B0, B. So we don't have B2. It's B0, B1, B3, B4, B5, B6, B7. So you still maintain the same system. So from here, let me start with B7. Enter. Rotate. So R. I go to B6. R. A move. This is very shaggy. B5. RR. Enter. B4. RR. Enter. B5. B3. Enter. RR. Enter. So B7, B6, B5, B4, B3. I'm done with that bit. So we have A15. A was going up to 15. You can start from this below side. A9, A8, A9, A10, A11, yeah, A8, A8, and R, and A9, and RR, and A10, enter, error, enter, A11, enter, error, enter, A12, enter, error, enter. First I have to check something. So you have A8, A9, A10, A11, A12, so no problem. So A15, enter, error, like that. Okay, these ones we can move them a bit to this point, because here we have to input a power VPP. So a symbol, we can input something VPP, enter, to cover pin number 1. So fire, couple this point, this one, this point, then this one. Oh, sorry. Can undo it. So this one to this point, this one to this point, this point, this one. Now we have 2 pins remaining, which need to be copied. Of course, we have here, we have the clock, so I can copy. And I want to see which pin I'll choose for the clock. You have to be very keen when choosing it. So let's do the place of use pin 3 as clock, rotate. Then I'll copy this one, copy, and move it there. So I rotate again, and then I will wire them. We are almost done. Now we are there, but we have a problem, because we need to power our system. We need to power our system, and to power this system we shall need a power source or a power input of 3 voltage, and therefore to end this we have to do, we don't have option apart from doing another schematic for the power supply system, for this, specifically for this input. We shall be powering the system from our laptops, and our laptop port always gives 5 volts, and this system, the PCB, this one, the STM32 miniboard, will require around 3.3 volts, and to get that 3.3 volts we have to design that system, and therefore we have to look for a beta IC that can give us this power. So what we do, we can look for one IC online. We have been doing all these designs, but I want to do it step by step again. So I would like to use AP2210 voltage regulator. The data sheet, we see whether it's a good one for this system of ours. So as we wait for it to connectivity is connected. Today we have slow internet, but there is no problem. We have to work on. So let me try to search it on my system too. Yeah, we will see it there. So AP22, AP22, 10. So it's not available. Okay, let me check at AP11, 17. Yeah, it's here. AP11, 17. You can take this symbol. You can see it's a 3v3. It's here fixed output. Yeah, it's not a bad one. It's a good regulator. You import it there. So because you have switched to this type of regulator, you come to the internet. Okay, you try to search for its datasheet. AP1117 datasheet. 1115 datasheet. AP1115 datasheet. So we are here. As it loads that one, we can load others. So we can load as many as possible. But the one that loads very quickly is the one that we shall be using. AP1115 datasheet. Let's see, look at that one. You don't buy an IC without data sheets, so let's check out today's one. So download it. So you can reach on DJ key. Hey, what a slow internet. So here we go. We have the datasheet application. So this one is being fit on comparators. Yeah, here is how the connections are done. You can see how the connections are done. Okay, we out in ground 100 capacitor, but it's advisable you can use even more than these 100 capacitors to because the higher the capacitance, the less or the more the better the signals that are being produced by this IC. But you can see we can use 100. Okay, thank you. Let's go on. We go on now to our schematic and continue with what we were doing. We were here, so let me enlarge this one so we can try and see. So here we must have a capacitor. So capacitor. Don't want to copy the one that I'm used to copying. Capacitor. So you have capacitor small. Like we will use a polarized one, but polarized, small and polarized, like that. Then I edit the value V and then put 100 microfarad. I've used exactly, and then I copy this to the output also. Then I'm going to add another one capacitor here. Cup. But now I'll use the polarized small polarized cup. This one. I'll input it here. Like that. With the value. For value I will use 470 UF. Okay, this one is to improve on the signal processed by this. Then I'll wire. Then I'll wire wire for wiring like that. Wire like that, like that, like that, like that, like that. So this one can take an input of up to 12 volts. An input can be up to 12 volts, so but I want to power it with 5 volts from your laptop. 5 volts. You will be using your laptop, but it can take an input of up to 12 volts. But so let's to power it. Then on the other hand again, power. The output now is 3 volts. Correct, like that. Then wire. Like that, control save. Then we can add some ground. GND, GND. Like that. There. All this. But first, wire. W like that. So you take this one there. You take this one there. Control save. That's your power supply circuit, the output. Now you have a nice system. Move. Okay, you have a nice system that is complete. You have a nice system that is complete. Then move it to that end. Copy this. Move it to that end. We copy this. We move it to this end. Okay. Control save. I can enlarge it for you to see everything. Still enlarge it. Still have all the spaces. Correct. Now this is our system. This is our system. It works like that. We have the power supply system here. 5 volts. This one you will be powering using your laptop. You power your board. And then you go to we have a voltage regulator here, which will now regulate the voltage to 3.3 volts, which will be the output that will come and power this board here. You can see here we have 3 volts that are required here to power this system. The what they call it now, the STM32F031K6. And then this one is the pin outlets. The pins, also the pin should be powered. You can see the power 3 volts power. So they must be powered. This same thing will be powered by 3 volts. This one will be powered by VPP. And you know where this VPP is coming from, this side. Any question? No. Of course, if there is any question, you can drop them at the bottom side of this video on our YouTube channel, and we can reply to all the questions and all your worries. So we can move to the next level of this, is to annotate our schematic. So we can annotate, annotation complete. We can close. Then you go to the next, is electrical rules check. Let's run it and see. You can see we have a total 3 warnings. They are just warnings, so they are not errors. And to end those warnings, what you do, you see here, we don't have where the power is coming from. That's why you are being questioned there. So we know what to do with that one. Again, this one is ground. Okay, I can move this one. Move. We see whether the error will persist. Wire. So wire. We see add the wire there. Okay, I can delete this one and delete the junction. I want to delete the junction. Control save. I can delete wire. And now add the wire the right way. Then I can add the wire in the right way. So you come here, wire, then you add it. No, there will be a problem, so I can delete junction. Let me first control save. Let me check the electrical rule again. We'll see whether they will disappear. Run. Close. So you have removed it from there. So you have to look at it again. Where it is electrical rule. Electrical rule. We have it here for VPP, and we have it here still, and we have it here for ground. So what you do to end this mess, you add our power flag. PWR, power flag symbol. I've got you rotate it, so I can input it there. I can copy, like that. I put it there. I copy it. Then I come and add it. I can rotate this one. I add it to that point. And then again, I can control save and then check. Do the electrical rules check. Run. So 0 warnings, 0 errors. Close. They were just warning. Many was schematic was good. It could proceed to the next level. So we go to the next level is addition of footprints. So we want to add some footprints on the system. So okay, very nice. So we have our capacitors here. The first capacitor is C1. So let's try to check something from this side. C1. Of course, C1 should be electrolytic capacitor, so we go back. I think it will be the only electrolytic capacitor, C1 and C2, exactly. So you come back here. So you go to capacitors, SMD. I like using this one, electrolytic. Control save. So we have our C3, C4. Again, I'll use electrolytic. Now that one is done. Now from there, I go back to normal default SMD16 08. 0805. Do I have 0805? So the ferrite we have is THT. Let me see at its reference how it looks like in the radio symbols. Okay, I have no option other than to use one. Then we have connectors. For these connectors we shall be using go to corner. Okay, 0, nothing. And with this is how it looks like from the symbols. But a good one. So we go on connectors. Let me see look at this one. How does it look like? Yeah, but a good one. So we still go on this family. I'm looking at different families because I want to see what is happening there. That's a good one. Heroes connectors. That's a good one too. This one looks better too, but it's a 2 times, so I need a 1 times. So again, they got disqualified because of the fact they are 2. Isn't there 2 again? JST, 1 times 12. These are now the connectors we should be looking at. Yeah, correct, you see. But I don't like the color. Don't know how I will change this color. This one is white in color. I need to do something to do with green or so times 12. Times 12, let me see the color, how they look like. They are all similar in color. They have the same color. Okay, let me check out other companies. We have the Molex. Maybe you at it. They are fake, I don't know, like the fact that they don't have phonics. Don't like the fact that they are facing, or do we have a different type of phonics? I like the fact where they are facing. Okay, let me check out Phonics MC is a different company again. You see what they have to offer for us for this one. Now, these one are better. Yes, these one are better. But before you go, you can check out Phonics high voltage. Although you are not using high voltage beams, so the high voltage is not necessary for us. Not bad ones. Phonics. MSTB, we see at the total. A different type. One the others are facing up, so we see this pin, nothing is there. Pin header connector, we see what they offer for us. I think they are the best. They are the best for this project. But now, I don't want horizontal, I want vertical. So I check at pin header connector, vertical. Really simple how it looks like. Oh my goodness, this is the thing. Here we go. And you have pin header connector SMD vertical. Let me see what they have to offer. But SMD they are not strong. Okay, SMD they are not strong. So I can use pin header vertical. These ones. And I come here, pin header vertical. Pin header vertical. Then I go back here. Pin header vertical. No, this one I can use horizontal. Is it? because you see the horizontal, they'll be looking outside like that. That is correct. So we got to switch. What do you get our switch? Switch. Potentiometer, push button. Resistors and the numerical shielding. Screw up box. So we look for the switch module. Not a good one. Okay, switch. One socket, nothing is there. Switch up to electric tie mounting module. So this crystal, let me do it first. Oh, I don't want that one. Okay, crystal horizontal, I don't know. I don't like it. Let me check that one. I don't like it. I want square. Not a good one. Oh my goodness, I want a nice crystal quartz. I want a nice crystal quartz. Yes, I needed a nice crystal quartz and I could get it. I knew I could get a nice crystal quartz. I don't know why it was trying to run away. I don't know why it was trying to run away. This one. You're going to packages. Packages B. Now here you have to look for one package. View. Don't like that. I want a square one. I think now I need a square one. I don't like this one again. So 4x4 times 6x6 21 times 10x8 millimeters 6x1. This one is not a bad one. Let me see. Let me have a look at it. It's not a good one, but not a bad one. So yes, package 32 7x7 was my dream. Hey, there's no hurry in Africa. You just do things the way you want. I wanted it 7x7, 32 pins. Now we have the final one. I have to decide what to use. I'll use a fuse. If it's a fuse, Okay, we go on. There we go. Control save. There is nothing here. There is no any component you have not added to footprint that is in 2D. So we proceed. We go to generation of netlist, generate netlist, save, and then BOM, generate. BOM are very important because when you want to send these things to manufacturer, that's what you'll be sending them to. Okay. So you have to update 0 warning, 0 errors, save, close, remove it at the center there. Then we expand it. We expand it. We expand it. We expand it. We can reduce it a bit, yes, like that. You can see this is the board that you want to see. Let us view it in 3D view. We see what is happening. Yes. We're having our board like this, but I don't like these ferrites. So let me try to see whether we can change it. Let me see whether we can change it a bit. But it's not a bad one even if it remains there, because this one is what is in my library. Let me see whether I can try to change it. Okay, like that. Work on footprints. Where is it today? The ferrite. Okay, for the ferrite, we'll see whether I can try to change it. Ferrite, but we have only a THT ferrite, so we don't have any option. So we can go on with the design. look at this. This is wonderful. This is a wonderful job. Yes, this is a wonderful job. So we go back and we start doing some arrangements now. Want this one move somewhere there, because I need this one to move, and then you rotate. We see whether we can insert the footprints at an angle. Show this on the orientation. Then we see whether 45 degrees will work. Okay. Yeah. The orientation of 45 degrees is working very nicely for me. Very nicely. So I shouldn't have any problem with that. So you can move this one somewhere else, because you want to move this. Move. Move. And if you are again you are trying to do an arrangement, so you can move again. Where is it? 3D view, 3D. Yep, we are trying to take. Okay, I can change this footprint. Is too big. So what you do, I come here. I want to change the footprint. That footprint is too big for my system. I don't like it. I want to make it a bit smaller. That is for crystal quartz. Okay, that one is too big. For this package 7x7, I'm going to go first packages. We have 5. Then crystal quartz. We got crystal. Even in. Okay, we can generate again the net list, generate, save, then we come here and then we update again the net list, update, close. Let's see, let me view. Yeah, correct. So I'm going to close it like that. So we can try to view it. View the 3D viewer like that. Close. Now there's something we have to note here, which is very important, and that is we have to rotate this R, because I want to move this. Move first. Move it there. I do this. move it, and then rotate. I want to arrange it very nicely. Then rotate. Let's check again. Let's have a look at it. Inspect. Is it view? 3D viewer. You can see it's taking shape. It's taking shape. Output. Move the output so I can rotate it again. R. So this output will be the last one to come in. So we can go with them. This move. Suppose apply. C2. Move 3v3. Move. Yeah. The other one is this capacitor 3C4. Move. Yep, C1. Move. You have to C2. Move. R. Move. C7, C8, C9, C5. Let me go back here to see whether it's called C2, C4, C3, C1, C2. Okay, it's true, C2, correct. So I have to look for C2. C5, C6, CUW, C7, C2 is here. So let me view the shape it's taking. Okay, we can see it's taking some shape. Rotation. Can even move. Now we want to view it again. We see what is happening. So what I was doing was just I'm trying to arrange this one to get at least to a better place. Okay, it's somehow better, but I can make it better again by moving. It's getting better and better and better, so you can move this one. view again, we see. So up to this point, we have our board. As you can see, it's a very nice board. So you can still move this one, move. We'll still make our board more small. Move. 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 So we can view again, we see how it looks like. Okay, not a bad one. So it's a better board, it's a better version. Control save. Now we can try to do some routing of this board. And route, I want to change the thickness, I want to make my thickness, my own thickness, the one I like. Routing, I'll do it very fast because of time. 2.2.3 no, 0.78. Okay, so that's how. Then you come and select the routing trace that you have made. You can use it in the design. So we have it like that. Now we start the routing. This one ends there, ends there. This one ends there. This one ends there. This one. There is no way it can pass. So you can place a view like that. Then you go to the bottom layer. You go like that, like that, like that, like that, like that, like that. Then you can place a view to the point you want to come up. Then you finish up your sketch like that. Control save. You go to the next part like that. You want it very quickly like that. Very quickly like that, like that, like that. Very quickly like that, like that. Very quickly. You do them very quickly. The one that's got to be done very quickly, you do them very quickly, without hurry. You can see again, you need to place a view. This is over here. So you go like that. Press another view there. Then you finish up your. You can use thinner line there like that. Finish up like that. And then you continue. You go back to these ones you can use. And then you can do them very quickly. Very quickly. Do not worry about them. You can be done very quickly. You can be done very quickly. Connect all of them. Use a view. Finish up the connection like that. Can use a view. Point. Can use over here. Connect can use a V again. So that's how we do the routing. You make sure all the parts are being routed. Let's view it, and then you see what you're getting. Okay, wonderful. Now we need to draw the edge of this object so that we can have a definite shape for it. Okay, you pick the part. I was worried. I was wondering what's not happening. So you go to this point, like that. You come to this other end, like that. You move. And you look for okay, sorry, like that. Then you can control save. Then you try to view it. You see, determine. I've done an error intentionally so that you can see what happens when you make an error in connection. So you come again here until you get that circle. That's when you do a connection. You come again to this side, you do that circle. Then now we view, you see. And see. You can see your board. Okay, we can enlarge it a bit. Yeah, this is our board. We can try to preferences. Yeah, you see then display. Okay, everything can be okay. Like that. Come here, you can try to board setup. Okay, roles, text, track on solder mask paste, text thickness, italic, keep text layer line like that. Okay, layer, PCB thickness, can make it 0.8. Make a couple layers. Okay, then now you can view it again. The viewer, as you can see, it has a nice now thickness. The board has nice thickness, so you can finalize by adding mounting holes, so footprints. Come to here, let it load. You can add mounting holes with pad. Okay. And I can import it here. Then the other mounting hole, can import it here. Then another one, can you put the final one here? You have 3 holes. Then you can click on view. You see what is happening. Ready viewer. Okay. You can even decide to insert 4 holes, so you can continue. Okay, there is no crime. When your board is firmly fit, then you can view it. The viewer. Okay, and then you can now insert your name. So we can do what we call copper pose on this board, the ground. This is the final bit you're going to do in this board, so that we can call it the day in this PCB design, like that, like that, like that. Then you can come to the final layer, which is the bottom layer, again ground. Okay, like that. like that, and like that. Then now you can view. Okay, I can like raise in size. So this is our board. This is our board that we have made using the SMT. So I can try to change the colors. I like nice colors. I like, you know, I'm a Chelsea fan, so I like blue. Okay, solder mask. I like blue. And you know, most of these boards are blue, but today I'll not go for blue. I'll go for green, saturated. Okay, that's our board. But I can again change the color. If not green, I can use another color. Solder mask. I can change it to black. Okay, somehow black, and then I can go again to preferences and choose the color of the background color. Bottom color, can choose to red. Let's see what will happen. Yes, and that is our board. And this marks the end of our lecture today. Thank you very much for your patience. See you in the next class. Goodbye.